So we just got done with file 5. So let's go ahead and open up file 6. And file 6 is another DWG, and let's see what it looks like to us. So this, again, looks like file 1, 2, and 3. Even it looks like file 5. So to our eyes, it looks exactly the same. And again, we stress the idea of, okay, well, that is interesting. Let's see what he's made of. And right away, those of you who know Rhino know that that's kind of weird when that happens. It means that things are very close to another, and Rhino's giving you the opportunity to sort of choose the right thing over the wrong thing. So instead of looking at things, let's look at one of these, whatever we've been shown, and it's a line. And if I just grab everything out here, what I see is there's 919 curves. If I get the details on all those, it probably is not going to be happy because it has to do a lot of data management for me. But yeah, it's very not happy. But basically, we can go right through all this and we can see it's all lines. So in this situation, which again, AEC industry, you know, can happen, you've been handed a set of information which is all faceted. Now, does this mean that we can't do the problem? Absolutely not. But it's going to be way different, a different solution than these particular solutions that we've already come up with. So let's go back to the drawing board and the input-output board and develop an algorithm which can take in 919 curves and convert it into something that is smiling. So in Grasshopper for file 6, we've noticed a very interesting difference in the data that we were provided. And I'll have you remember from back the very beginning, we were talking about the fact that the empathy with the machine is very important because for us, we need to, from first principles, being able to understand that a face, we have defined it as eyes, mouth, and an outer face. We kind of understand on a generic level, that's what a face is. But the computer didn't know that back then, and it doesn't know it now. And what's interesting about the problem that we've had, what we have now is, and we even had this a little bit in the previous file, which was the fact that effectively, before we were saying there was an outer face, right? And that there was a couple of eyes, and then there was a mouth. And in general, that was kind of a one-to-one. If this were the programmatic side of things, the objects that we had was a one-to-one to our first principles side of things. Yeah, so we know that this is first principles, and this was the data. Now, in the previous file, that actually sort of changed. So first principles dictates basically, again, these are the eyes. This is the mouth. And this is the outer portion of the face, yes? So this is very important because in the last episode, we were talking about the data being made up of, yes, there was an outer portion of the face. Yes, there were a couple of eyes. But actually, what made up the mouth was a couple of different things. So we've already stepped into this realm. We talked last time about how this could have complicated things a lot more than it did. We just happened to choose the right algorithm. In this case, we've actually moved it way past a situation where we could actually get away with that. Because now the data, the first principles of the problem still is 1, 2, 3, 4, if we were going to draw it. But the data that we've been given is basically 100, whatever we said it was, about 1,000 just little pieces of information. And there is no direct linking that we can see of that information to the first principles of the problem. So that really is the problem that we face. So if that's the problem we face, how do we resolve it? Now it's straight up, we understand the data, we understand the first principles of the problem. So really now it becomes, how can we
solve the issue of we have not a one-to-one parity between, not just do we have a one-to-one relationship, let's say, between our first principles and data, but just how do we solve the problem? So let's start from here, actually. That's the input, and the output is this picture, yeah? So what are we going to do? And this is where a little bit of CAD knowledge might come in handy, because we already have shown in previous lessons that if, for instance, we were able to identify which ones of these curves went with the outer portion of the face, which portions went with the eyes, and which portion went with the mouth, we could just play the game where we convert this information here into a point which, relatively speaking, would be placed there, and then just play the game of rotating about that point. So how can we, as easily as possible, be able to get it into, the key to being able to do that would be to the partitioning this list up. And in this situation, it should be relatively easy, because it looked like, and we'll have to test this theory, but it looked like we could actually reference in everything, right? And then be able to do a join operation. So it looked like we would be able to kind of, because the smiling face is, each part of the face looks distinct on its own, and it didn't look like there were necessarily any, if I zoomed in right here, any sort of gaps. But it looked like maybe we could do a join and bring everything back to a one-to-one correspondence with our first principles. So let's try that. So let's say the algorithm is first select all curves, and then let's say number 2 is join all curves. Yeah? And then hopefully what we'll have is, instead of having this guy, we'll have this guy, this guy, this guy, this guy. Again, drawing it in a way that the computer would kind of see. He just sees a list of information, yeah? And then at that point, 3, select mouth. So if we do all that, if we do all 3 of those steps, this will be a chance for us to be successful in this.